Hi all, welcome to the video. In the last video, we looked at how we can import the dataset and then how we can, initialize an isolation forest object and specify certain parameters using this particular piece of code. And then we can also check the amount of time it takes to actually train a model. Now our model is done. Let's predict. So ours was a train.tf and then we'll use the ISO object. Okay, and then we'll basically use it to predict. I hope it does. What's happening? Yeah, so you see, okay, so let me name it as train.tf2. Okay, so you see, once I basically use the ISO object to predict, it creates an anomaly score. Okay, so just for this, let's try and arrange the data frame based on descending values of anomaly score. I mean, these are the values which are actually anomalous, which have a high anomaly score. Okay, so you see there are certain, uh, the thing is it automatically also creates an ID. I mean, ID 437,281 is nothing but row numbers from our original dataset. If you look at train.tf, there are no such IDs. However, the IsoPredict what it essentially does is, apart from creating the anomaly score, it also adds an ID. So our train.tf is created. Now, it is one thing to basically train and predict the score, but how do we actually, visualize things, and what are the steps to actually make sense of the output? So we will basically do a dimension reduction, and for this we will be using the uwat library. And the first thing is basically to, I mean, yeah, it has an anomaly score, so therefore I am using the train.tf, which just have the independent variables. So I will first scale it. Okay, so once I scale it, and I will then use a dimension reduction using the uwat library. Okay, and I think there is a umap, yeah, umap function there. And let's look at things. Okay, so the thing is, it essentially compresses all the other variables into 2 dimension. Let's I think set names. Yeah, there is a function known as set names, by which I can give names to these dimension 1 and dimension 2. Okay, and then I can again convert that into a tibble. Oh god, what happened? Oh, I missed the comma and the closing. As underscore table. Okay, now if I do that, you will basically get a pretty table. So you see, we essentially got 2 dimension. Oh, why was it not named? I think the default setting is to basically have v1 and v2. Okay, no problem. Okay, now the thing is, if you look at things, the one essentially corresponds to row number 1, 2 essentially corresponds to row number 2. So let's create an ID column, okay, which is nothing but running counter sort of things, which will be used as an index or a key to join. Okay, you see, so we basically have the IDs now. Now let's try to bring in the scores also. Left join. Okay, so my score is basically in train.tf. Okay, and let me just select anomaly. Um, okay, or let me just specify the ID. Okay, just a second. Okay, let's see. Okay, so you see, basically what we have here is the reduced dimension, corresponding row number, and then the anomaly score. Okay, let's call it plot.tf. I'll be basically plotting this now. Now we just need to understand across these two dimensions, v1 let's say on x-axis and v2 on y-axis, how is my anomaly score behaving, and what is there any trend? Okay, so this I can basically do using plot.tf, and I can do ggplot, and in aesthetics I can mention v1 v2, and then let me add another layer of geom points. Okay, so geom points is nothing but your anomaly score, but here we'll be basically using some aesthetic filter to modify the size of the score. Okay, let's see plot.e. Oh, okay, my bad. Just a second. Okay, now you see, we basically got this, got the plot or the spread of the anomaly score across these two dimensions, and we can definitely see that the points that are to the far right, which have a high anomalous score, you see the size of the balls. If you look at the size of the points, uh, the ones that are to the right are around 0.70, and these are the ones which have a high anomalous score. So essentially, this is the way you do an isolation forest. You first take the data set, you then divide it into test and train, and then you train an isolation forest. Some of the key functions of training an isolation forest are, you first create a new isolation forest object. Once that is created, you then fit it into tested trained data set, and then you use it to predict. So new, fit, and predict are the important, sub functions of an isolation forest object. And once you have it, you basically if all your variables in your data set are numeric in nature, so it's a good practice to basically compress it so that you can see on a very high level what exactly is the spread of the score across the broader dimensions, and then you can obviously see the plot as well. Uh, in short, if I have to just pick the scores, or if I have to just pick the observations which are anomalous in nature, or which are what you can say diabetes from our original data set, which are basically the patients which have diabetes. So these will be the ones which will have a high anomalous score. I hope this video was useful to you. I know it was lengthy, but yeah, it was an important concept, difficult concept to grasp. Uh, uh, do subscribe to my channel if you think the content was useful.